So welcome to Ignite, and welcome to the presentation, 15 minutes to improve your Python app in Azure. My name is Kate Olszewska, and I'll be your host today. As you can see, I've been working on this for a while now, but I'm a PM on the Azure Developer Experience team. And what we really work on right now is trying to really improve the experience that the Python developers get when they are trying to interact with different services in Azure. We're really open to feedback, and we're always trying to learn better about how to serve you. So if you have any sort of experiences about what we're doing right or what we were doing wrong and could improve upon, feel free to reach out. There's a couple of different places where you can contact me, and we also have our own booth close to THR6, somewhere right there, called Azure SDKs, and you can find me there afterwards, and we're really open to listening about your experiences. So diving right into our most recent efforts, I'm happy to announce that today we're releasing a couple of new Python libraries for different Azure services. And this effort comes from a lot of work that we've done over the last year to really reimagine the way we serve them. There's a lot of things that we've realized that we really should be doing better and improve upon in order to make sure that you have to write less code, it's easier for you to actually learn what to do, and it's more intuitive to you as a Python developer. In order to reach these objectives, we really set a number of different standards and principles that we wanted to follow ourselves in order to make sure that we actually able to provide you with that experience. So I really want to give you a better idea of what those are in order to better be able to develop with them. The first one is consistency. Before, if you tried to use a couple of different services, you might be able to learn a certain pattern in, for example, storage, but then you would quickly find out that if you tried to combine it with some sort of other service, you would need to relearn some different practices because they were owned by different services and really provided separate experiences. What we wanted to do is to provide that common set of patterns that you can learn, that you can actually use over and over again. And we'll see that in a bit. One of the most common and main things that we really wanted to focus there is consistency in terms of naming. Whatever service you use, you're going to see that it will have the service name followed by client. And it's usually your main point of entry to actually be able to use that service. So if you're looking either through reference documentation or if you browse through IntelliSense, you'll be able to find that client is your first best bet to actually interact with this. The next thing is that we really try to include a number of common features that you will be able to reuse all across different services and different methods. Some of that is, for example, a timeout policy, which you can use in order to make sure that you have a set of standards where when you're building a reactive application, it's really set in order for you to be able to implement when it's going to time out. We also support both synchronous and asynchronous methods, which means that before, when you were really focused, asynchronous really provides the best way of patterns. But if you're trying to build just a simple script that's doing something, or exploring a new service, it might be too complicated and people struggle with it. So we also provide a set of synchronous methods. The next big focus is making sure that the libraries that we provide are truly idiomatic, which means that before we've been accused a bit that all of our libraries feel very C#-ish. And I'm happy to say that this is no longer the case. We have an entire dedicated Python team that really understands both the language and the community around it. So we really try to focus on making sure that the calls are simple enough and understandable to you as developers. The next set of things that we really implemented is a set of coordinative cloud features that are really necessary to have these days in order to interact with cloud services. Things like authentication, retries, logging, and so on. And we're going to dive a bit deeper into that in a bit. The next principle we've had is discoverability. All of this makes sense only if you're able to quickly find the information that you need in one place. All of our code is open source on GitHub, so if you go to github.com/Azure SDK for Python, you'll find all of the different SDKs right there. And we also provide sample code and quick guides to get started quickly in order to actually implement and use the code in your applications. We're really open to contributions, and we're trying to build a better open source community around it. So if you have any sort of issues that you submit, any sort of PRs, we're really looking forward to them. And if you submit one, we scout through them every day. So you're probably going to get a comment from me right after that. The last thing that we really wanted to focus on is documentation. For Python explicitly, missing documentation or not up to the expectations that you would have, Python has always been the main offender. So we really try to make sure that the libraries we have really follow the pattern of having a lot of different samples, a lot of different parameters, everything documented a lot. So that's why I also wanted to show you an experiment we did in order to actually presenting documentation in a slightly different manner. So you can have an idea of what you can see, and you can browse through different services. Another example of that would be specifically for storage. You can see for the main service client, you have all of the parameters, everything described, as well as examples of how to actually incorporate that in your code. So if you want to check it out, you can always go to our aka.ms/Python docs. OK, so without any further ado, I just wanted to show you how exactly that looks like. So let's dive right into the code. So here's a very simple code snippet that I wrote in order to show you how easy and quickly it is to actually develop with that. I don't know if you can see, but let me zoom in just a bit. The first thing that you're going to notice is the authentication element. Before, authentication has always been something that has been a main challenge, because different services would use different authentication methods, and being able to interact with any of them would set a lot of different challenges, because you would have to make sure that you cater to each and every one of them. Now, as you can see, I'm using something called default Azure credential, which is truly the thing that we are expecting most of the developers to actually use. The default Azure credential in itself actually uses 4 different methods that it's querying, and it picks the best one out of them. After I authenticate it, I set the blob service client, because what I want to do today is upload a picture to my storage. And the way I constructed the client is very simple. I point to my storage account right here, and I pass on the credentials that I just got from the default Azure credential. Once I got that, I can actually interact with my storage account in any way that I want. So I get my blob client to point to a specific blob that I want to upload the data to, and I just go ahead and upload it. The other thing that I wanted to do today is also to point to some of my secrets that I stored in my key vault. And as you can see here, the way I set it up is actually exactly identical to the way I set up my blob service client. I only pass the URL to my key vault, and I pass on the same set of credentials that I use for storage, which means that now I can use the same method of authentication, and I only need to do it once. And after that, I'm only getting my secret, and I'm just going to show you the value of my secret. OK, so let's try to get this started, if the network allows. OK, so as you can see, for storage, it mentions that it's done, and it displays my shameful secret as well. So we managed to successfully get all the information. Just to confirm, this is the portal, and you can see that before I had no blobs, and now I have my live demo right here. So you can see that it truly took like 5 lines of code to just do all of that. So it's really, truly easy. OK. So you could see a couple of very basic operations in action, but we truly tried to cater to every different developer and all the needs that you have, either on the getting started side and on the more advanced pushing the things into production. That is why all of our SDKs rely on the Azure core library that we developed that is all of our libraries take a dependency on. The Azure core implements the HTTP pipeline of policies, which are you can still edit them and add your own as well. What they do is that they either edit the requests or change the response as well, so you can actually use them in your own way. The first thing, going through the things that we've done, is the client request ID policies. What it does add the client ID into the HTTP header so that you can actually follow each of the requests in case something happens. Assuming, for example, the service doesn't act in the way you were expecting it to do, you can hop on a call and call the support and actually easily identify which request did not go through and why that happened. Another thing is the retry policies, which is truly crucial to the cloud applications. Again, in case of any sort of errors that happen because the network does not work correctly, you can have an automated retry policy set up, and it's going to retry to send the request in a specified intervals or a number of times. Another policy is the authentication. So I mentioned the default Azure credential that I was using before. And what it truly does is that it tries all of these different things first in order to pick the best one. The first thing that it does is it looks for the environment variables, and it should pick them up from any platform. If that doesn't work, it reverts to manage identity credentials, which would work if you have your applications deployed in Azure, and it can pick them up from there. The next method it uses is the shared token cache, which it truly is the single sign-on. If you, for example, use Visual Studio and log in with your Azure credentials, it should pick them up. We're also trying to plan to use them in a number of different platforms like Azure CLI and PowerShell coming soon. Another thing that we have is interactive browser. So if all of these fail, it will try to pop out a browser window for you to log in as you would normally do. This is great because it really lets you use them both in the developer environment as well once you deploy in your application in the cloud. So you truly would not need to worry too much about it if you use it. That being said, you can still use any of them individually and whatever is the most convenient for you, as well as a couple of others and a number of service-specific ones that each service supports. Another feature that we have is logging. So you can monitor all of the requests and responses, or, for example, all of the failed responses that come in, and log them either locally or in one of the cloud provision solutions. The next thing is the buffer response. So if you're trying to download something, but the response does not go through because of some network failure, it's going to automatically retry to try to get the response. The next part is distributed tracing, where you can actually track all of your requests as they go through a number of different services, and again, be able to identify where it went through, what happened at each stage. The transport layer is set to the HTTP request, but you can also configure it to take it from local cache or anything else that you define. And as I mentioned, all of this is fully extensible, so if there is anything else that you would like to build on top of it, feel free to do so, and should not be that much of a burden. So just to reiterate everything that we've discussed and truly push you to where can you go next, you can find all of our libraries on GitHub. So github.com/Azure SDK for Python. The three libraries that are currently available are storage, Key Vault, and identity. And very soon, we are also releasing event hubs, Cosmos DB, app configuration, as well as trying to look into a lot of the deployment-oriented libraries in the management layer. If there is anything else you believe would be really critical for your applications, please do let us know, and we can look into that. The documentation site that I was using, you can find under this link. And we also have another talk where one of my friends is going to be going through actually trying to build an entire application from scratch. And he's going to be using some of our Cosmos DB libraries that are currently in preview. Feel free to check it out. It's on Thursday, and it should take 45 minutes. We also have, as I mentioned, our booth. We have a couple of different challenges where you can try out to code something up. And we have some prices, and it's located right there. feel free to stay in touch. We have a Twitter and our GitHub, and you're always welcome to contribute and talk to us. Thanks.